Hi guys, today we're going to be looking at this idea where we're going to be integrating between points bounded by the x-axis. Now what that means is you're going to be having to find the areas under this curve that fit or are locked in between the curve and the x-axis. So in other words, we're going to be finding these areas here. Now before we start going and doing some problems, there's a few things we just need to be on top of. One is our curve sketching skills, so you are going to have to be readily sketching some of these curves so you can understand what's happening with the problems. And the other one, the main one, is understanding the value that you would get if you substitute between these 2 points, between 0 and A, and also understanding the value you'd get if you're substituting between 0 and B here. They're going to be two very different things. So in this case, if we were asked to find the integral of this function between B and A, we couldn't just go and integrate that function and sub in those values. Does anyone know why we couldn't do that? Yeah, the reason we can't do that is because of this bottom section between B and 0. All right, so really what we'd have to be doing is two separate type of questions. Go between 0 and A, integrate that, and then add it to, now wait for it, the absolute value of between B and 0 of that function. Why did I say the absolute value just for that section? Yeah, that's right, because this is going to produce a negative value. Now we know an area, something taking up some space, can't have a negative value, so we've got to change it to be a positive, which is why we're using the absolute value. Now you don't have to use the absolute value notation, as long as you're remembering though, if you get that negative answer, or when to look for that negative answer, that you change it to a positive value and then add them both together. For example, if this value that you got was 5 and this was negative 8, if you just went and put in your calculator this top section, in other words, found the area under the curve between B and A, you would get yourself an answer of negative 3. All right, and we can't have an area of negative 3. We can certainly evaluate that to be negative 3, but if we're talking about areas bounded by the axes, we need to have that positive value. So it's the absolute value of 8. You should be getting yourself that answer of 13. All right, I hope everyone understood that little description. Now let's go and try and do some problems. Okay, example 1 from your student workbook says, find the area enclosed by the curve 2 plus x minus x squared and the x-axis. Okay, so keyword there is area enclosed by that curve. What's this going to mean is we're going to have to integrate, all right, because integration gives us the area under a curve. But we're looking for the area enclosed by that curve and the x-axis. So we're not actually given some perimeters to work with. So what we're going to have to do is go and sketch this curve to see where we're going to integrate between. Okay, so first off, having to sketch this function. Okay, so I've taken a negative factor out the front so we can then go and factorize and find these 2 points where the curve's crossing the axis, because these are super important, not just for our sketch, right? It's upside down parabola, but also for solving this problem. All right, so what this problem actually asks us to do is to find the enclosed area, right? So think about having a fence with a bit of land, which part you're closing off. Between the curve and the x-axis would be all of this area in here shaded blue. Okay, so that is the area I'm trying to find. It's the part that's between the curve and the x-axis. Right, closed off by those 2 points. So essentially, what this question is asking us to do is this. Integrate between 2 and negative 1. And I forgot to put my negative 1 with that one there. we're going to be integrating between those 2 points, and we're going to be integrating 2 plus x minus x squared dx. All right, so that's the question we're essentially being asked to solve. Not very different to the last little unit of the work. All right, but this time we've got to do some pre-thinking about that function and what it looks like to help us find these 2 values we're going to integrate between. Okay, so if we go and do the integrating now, right, this will give us the area. We're going to add 1 to the power, divide by the new power, which is just 1. Add 1 to the power, divide by the new power. Add 1 to this power, divide by the new power. Now there is no plus c, don't forget, because we've got these limitations in place. We're now going to go and substitute. Okay, substituting 2. And from that, we're taking away the substitution of -1. All right, and now it's just purely a calculator exercise, and we hope we don't get this part wrong. It's going to tell us 4.5 or 4.5 units squared. Okay, example number 2, it's and also undefined. It says find the area bounded by the curve y equals x squared minus 4 and the x-axis. All right, so same as last time, we're going to start with a sketch. Okay, in this particular function here that we've got, it's our normal parabola that's been shifted down 4. All right, so normal parabola coming down 4 units. Okay, we've also got to think about x-intercepts. So it's when y is equal to 0 for this equation. So when 4 is equal to x squared. So x equal to plus or minus 2 square root of 4. All right, so value of 2, value of minus 2 there. All right, what does this tell us about the actual question we've got to answer now? Because it says find the area bounded by the curve and this function that we've just sketched between it, this function and the x-axis. What that means is we are going to attempt to find this area in here. Who can tell me something about this area we're going to find? Yeah, that's right. If we did integrate between 2 and -2, it's going to give us a negative value. All right, so all we're going to do with that is at the very last minute take an absolute value and change it to a positive area. All right, so we're going to integrate this function between 2 and -2, and the function is x squared minus 4. All right, so that's all we're going to have to do, and then we're going to take an absolute value at the very end. Okay, so integrating the function now, add 1 to the power, divide by the new power, add 1 to the power. And now we're going to substitute between 2 and -2. All right, so substituting our 2 and then taking away our substitution of -2. Okay, so when we do put this in the calculator, as we said, it's going to give us an answer of -10 2/3. All right, so we know the area is going to be positive 10 2/3 units squared. All right, if you want to go and put your absolute value symbols in, you can. All right, that could be a good thing to remind us. I mean, even if you want to do it at the top when you initially think, all right, and go and put those absolute values in there, because you know that when you put this area that's underneath the x-axis in your calculator, it's going to give you a negative value. Okay, example number 3, and it's upping the ante here a little bit. It says find the area enclosed between the curve x cubed, so a nice easy one to sketch, but between the x-axis and the lines x equals -1 and x equals +3. Again, let's sketch first. Okay, so here's our curve y equals x cubed. We're going to be finding the area between 3 and -1. All right, so there's our line -1. Here's our line +3. I mean, these lines do continue on, but we're looking for the area bounded by the curve and these two lines. All right, so essentially we're going to be finding the area of this section in here between 3 and 0, and the area here between 0 and -1. Now, who can tell me something about this problem? Yeah, this part down here between 0 and -1, that's going to give us a negative value. And this part here between 3 and 0 will give us a positive value. All right, so we're going to have to do something different, because if we just went and did the integral between 3 and -1 of the function, we won't get the right answer. All right, so we don't want to be doing that. Yeah, we're going to have to split it. We're going to have to do our positive section, so between 3 and 0. And to that, we're going to have to add the absolute value of between 0 and -1 of our function. All right, because this part down here will be negative, we're going to turn it positive. All right, that'll give us the true area between 3 and -1 and the x-axis for this curve. Okay, so this is what we're going to do. Integrate this first one. Okay, so it's x to the power of 4 on 4. We're going between 3 and 0 for that one. And then the absolute value of x to the power of 4 on 4. But this one is between 0 and -1. Okay, so now we just got to perform a couple of substitutions. All right, so there we go. Substituting 3 and then 0. And then substituting 0 and then -1. So now we put this all in our calculator and we'll get our values. So we're going to get ourselves 81 on 4 plus the absolute value of -1/4. So we're going to end up with 20.5 units squared for our area. Now look, if you find the working of this a bit confusing, if you are trying to put it in one big line, you can separate things, right? So you could say go and just integrate that and work down the page and get yourself a value and call that area 1, and then go and integrate the next part and again work down the page and call that area 2, and then just add together your two answers at the end. All right, so you don't have to do it all in one big line if it gets a little bit more confusing. And it could get more confusing, especially if one of those values is not 0. All right, but it's up to you. Do some practice questions and see what works for you. Okay, example number 4, and it says, find the area between the curve again, and it's the same curve, x cubed, the x-axis, and the lines -2 and x equals 2. Okay, so here's our curve, and here's our two spots. We're going to be finding the area in between the curve and 2, and between the curve and -2, and that bounded by that x-axis. All right, so who can tell me something about this picture we've got now? Yeah, that's right. If we were to integrate between 2 and -2, what we'd get is an answer of 0. Because both these two areas hold the same value, it's just that one is negative while the other is positive. All right, so what we've actually got here is an odd function, symmetrical about that y-axis. All right, so this is a special case where we can introduce another technique to make things slightly quicker. All right, so instead of going and just integrating like normal for this function, what we're actually going to do is we're not going to integrate between 2 and -2. We're going to get two lots of the integral of between 2 and 0. Now, you might still not say this is not going to make it too much quicker, right? But sometimes when you've got multiple sections that are similar, it could make it a lot faster. And in this case, it's going to alleviate the need to do the absolute value. Or really, it's going to make sure that we don't forget to do that absolute value of that negative area. Okay, so all we're going to do is find the area between here and here and double it. Okay, so double that area between 2 and 0. So it's 2 lots of 2 to the power of 4 on 4 minus our 0, or 0 to the power of 4 on 4. All right, and we go to our calculators. And it gives us an answer of 8 units squared. All right, all this means is each of those individual blue areas would have been 4 units each, except this one on the left, the between -2 and 0, would have come up in the calculator as -4. Okay, example 5, the final one for lesson 1. It says find the area between that curve y equals x squared. So again, good, another easy one to sketch. The x-axis and the lines x equals -4 and x equals 4. Notice this one didn't say bounded. All right, so we'll see what we mean by it not being bounded when we draw the sketch. Okay, so here we have our curve x squared. All right, so it then says, all right, pick these 2 points, 4 and -4. All right, there are 2 lines. And it says the area between, so it's not saying bounded by, because like I said with example 1, this curve hasn't got those fixed points on the axes that are like the fence that are sort of sectioning itself off. This one just says find the area in between the curve and those lines. So we are finding this area in here. Now it's exact same process, okay? It's just not bounded, all right? So it's an area underneath that curve where we stop at the x-axis. Now in this case here, we've got ourselves an even function, okay, symmetrical about that y-axis and mirroring the same on both sides. A reflection, not rotation. So all this says is this area here between 4 and 0 is going to be the exact same as this area here between -4 and 0. All right, so when we go and perform our actual integration to find the area of these curves, we're not going to go between 4 and -4. We're going to go between 4 and 0 and double it. All right, so it'll make things a bit quicker for our substitution. All right, so we're going to double up x cubed on 3, but we're only going to substitute between 4 and 0. All right, and I chose that right-hand side because I'd much prefer to substitute positive values rather than negative ones. All right, so we're going to get double 4 cubed on 3 minus 0 cubed on 3, which will give us 42 2/3 units squared.